Hello everyone. How are you doing today? Yes. It's nice to see you guys again today. So today we'll be done with section 3.6 and start chapter 4. So for this weekend, you chapter 3, all the sections, homework and quizzes, their due date will be Tuesday midnight. Definitely finish them by that. I'm not going to extend the due dates. Okay. So if you haven't have your MyMathLab yet, make sure you have it and do all of them. And later, eventually, I'm going to show you how much those MyMathLab assignments boost your grades. Without them, you may not pass this class. Especially if your exam score is bad, then those are your hope. Okay, any question before we start? Yeah, but the multiple choice still requires your correct work. So in the final exam, you'll have 30 questions, 22 multiple choice, and 24 multiple choice and 6 non-multiple choice. What deadline? I said chapter 3 homework and quizzes due date is Tuesday midnight. If you haven't done them last Tuesday, your last hope is next Tuesday. So definitely do all of them with as high score as possible by next Tuesday midnight. And your exam 1 will be February 19th, which is a Thursday. And then February 20, we're not going to have a lecture, but we're going to have a PLTL. Okay, domain and range. We already have some idea about domain and range. We talked about them at the beginning of section 3.6. Domain represent the X values, range represent the Y values. So when we started the relation was a bunch of order pairs. That's why when we stated our domain and range, we only stated the numbers, the whole numbers 1, 2, 3, 4. But let's see a continuous function that's going on forever, not just a bunch of points. So in that case, your domain and range, you need to write in interval notation. So you cannot specify a number because on the number line, every number you're going to include in your function. For example, if you have, let's say, this type of function, it's going on forever. So you cannot say our domain is 1, 2, 3, 4, because between 1 and 2, you have so many decimals. Between 2 and 3, you have so many decimals. And all those numbers are also inside your domain. So when you talk about domain and range of a function or an equation and the graph, then you need to write your interval, your domain and range right in interval notation. So it will not be any number, a list of numbers. It will be a list of intervals. Now, from a graph, if you want to find the domain, you need to observe what is the smallest X value you have on your domain until what's the largest Y value, X value you have on the domain. For range, you look at what is the smallest Y value we have on the range on the y-axis, and then until what's the highest Y value you have in the y-axis. So Y going to give you your range, X going to give you your domain. So X runs from left to the right, negative infinity to positive infinity. You observe all the points and see where your graph is running from and to it's stopping to. And for range, we look at upward and downward. So downward, we have negative infinity, upward, we have positive infinity. So you observe the graph on the y-axis and you list or you include the lowest y to the highest y. You don't list them, you list as an interval. So in general, when you write in interval notation, we write domain as the smallest X value, comma, the largest X value you see in the graph. For range, it's the smallest y value, comma, the largest y value you see in the graph. Now the boundary, you have two choices, you have three choices. Either you see parentheses, or square bracket, or curly bracket. You're going to use bracket if the y value exists at the end, where you're stopping the lowest or the highest value. Or if you don't see any graph, you don't see any hole or graph in your graph, hole or gap in your graph. We are going to use parentheses if your graph has a hole in it, a hole or a gap in it. And we use curly brackets when your domain or range has only one number in it. So for one number, we use the curly bracket. For hole or gap, we use parentheses and also infinity. Let me include the infinity. Hole in it, or it has infinity in it. So if you have a hole or it's continuous forever, it means infinity, then you're going to have parentheses. And if it's just a continuous, then without any hole or without any gap, then it's bracket. So three types of boundary based on three types of scenario. Now, let me start with a portion of a graph. Let's say we have a graph. This is our x-axis, this is our y-axis, and let's say this is, let's say we have a hole here, and we don't have hole here. And let's say we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, -3. 1, 2, 3, 4, 5, 6, 7. So let's say you have a graph. It's a portion of a whole graph. Now, if you observe this graph, let's find the domain. Domain is from smallest x to the largest x. So in this graph, what is the smallest x value you see? -5. And at -5, do you see any hole or do you see a closed circle? Closed circle. So for closed circle, what do you use? Bracket or parentheses? As long as you don't see any hole, what do you use? Bracket. No hole means bracket. Now, what is the highest x value you see in your graph? 7. And at 7, do you see a hole in your graph? An open hole. Hole is open always. If it's closed, then it's a closed circle, not hole anymore. For hole, it's parentheses. So when you have a hole or a gap or infinity, then it's parentheses. So if you don't see infinity, if you don't see a hole or gap, then it's always bracket. Go ahead. So at this point, what our y value is supposed to be? 7. But do you have any 7 here? At 7, there is a gap. So do you have any 7 here? We can reach up to 7, but then when you go exactly at 7, you just fall down. There is no stopping. If you can stop, then it's fine. But if you cannot stop, instead you fall down, falling down is a bad thing, right? You don't want to fall down. So when you fall down, it's a bad thing. So it's a parenthesis. So what parentheses tells us is that parentheses means go up to that number, but you cannot use that number. So you can reach up to 7, but you cannot use 7. At the place of 7, there is nothing. It's just an empty box, empty circle. So that's like anytime you have parentheses, it means the number we have next to the parentheses, it's not in the graph or it's not in the function. It's invisible.
How is the negative sign in the graph? Because doesn't it, the line crosses at -4?
Yeah, but what is at this point, what is your x value? Your x value. Tell me the point here. -5. And what is your y value? -3. And at this point, what is your x value? Remember, x comes from below. And what is your y value? 7. So at 7, 7, we don't have any closed circle. We have a problem. We have a hole. And hole means the number doesn't exist. The number doesn't exist here. Okay, now range. Range is the y's. So if you look at the y-axis, what is the smallest y value you see in your graph? -3, perfect. And at -3, do you see any hole anywhere? So for -3, we have a part here and we have a part here. In any of the part, do you see any hole in the graph? No. So if you don't see a hole, what your boundary should be? No hole means a good thing. Bracket. See, continuous without any hole. If you don't have any hole or any gap, it's bracket. And then going upward, what is the highest y value you have? 7. But at 7, do you see any hole? Yes, we do. So 7 doesn't exist. What I'm doing, the other way around. For 3, -3 is there, but 7 is not there. So -3 doesn't have any hole anywhere in the graph, so it's get bracket. But when you reach to 7, it has a hole, so it has to be parentheses. Okay. Now this is the scenario when you have a limited graph. But how about if you have a graph that continues forever and ever and ever? It's happily living after. No. What do you call the end of the story? Living happily after. Right? Living happily after. So it's living happily after. Forever and ever and ever and ever. So if we are going continuously forever on the left side, what is the smallest x value you have on your left side? You're going on forever and ever and ever and ever. -infinity. And if you are going on your right side, forever and ever and ever and ever, what is the highest number you're going to reach on the right side? Positive infinity. So between -infinity to positive infinity, do you see any gap anywhere in your function from left to the right? So what is your domain? -infinity to positive infinity. So domain means what x value you can point out here. So you can point out x value 5, x value 0, x value maybe 50, and then keep going on and on and on. So you can point out until negative infinity.
The same thing with this one. I think it went on the bottom.
Bottom is the range. So if you're talking about upward bottom, it's the range.
No, the opposite of this. Instead of going up, it goes down. It's not a domain.
No. Left, when you observe from left to the right, we are talking about domain. If you're observing up to down, then you are looking for a range. So a graph can be anything, but depending on how you're looking at it. Are you looking at it from left side to the right side or from up to down? So we looked at first from left to the right and we found that, oh, everything from the number line is in there. And so we can substitute x with any number and we get something valid for y value. How is the range? When you look at the height wise, what is the smallest y value you see in the graph? -4 is here. Do you have any graph here? 3. See, the graph starts here. So that is where we have our lowest y value, 3. So our range starts from 3 because that's the smallest y you can have in the graph. Now at 3, do you see any hole or any gap? So what will be the boundary? Bracket. Good job. And then if you look at upward, how high you reach upward in your graph? Good job. We got it. So the graph is going on and on and on forever and ever and ever upward. So the highest y we can reach is the infinity. And infinity always get what? Parentheses. And that's how you find dominant range. And a few of these will be in your exam. At least 2 or 3. So 2 to 3 will be in the exam. Any questions so far? We are not done. We have more examples. So now since you understood the concept, it's time for volunteering. Who would like to do domain here? Negative infinity, parentheses, infinity, parentheses. So this line is going on and on and on and on forever on the left. And we know the leftmost number is negative infinity. And this is also going on forever and ever and ever on the right side. And we know on the right side, we have positive infinity. So all the x values we have in our graph, from negative to positive infinity. Now range is an interesting thing here. Y value. What is the lowest y value you see in a graph? 3. Good. What's the highest y value you see in the graph? Still 3. So how many numbers do you have in your range? Only 1. So for one number, what type of boundary we use? Curly brackets. The curly here is curly brackets. So for one number in the domain of range, it's curly bracket. If you have a hole, it means parentheses, hole or infinity. And if you don't see have any problem, then it's always brackets. And see, here there is no y value we have in the graph. Here there is no y value we have in the graph. Our graph is a horizontal line. It has only one y value, y equals 3. And the equation of this graph is also y equals 3. It's a horizontal line. Any question? Can I flip my page? Okay, then. Two more. Try them and let me take the attendance. Find the domain and range. 2826. Andrea. Shake. Christian. Christina. Christopher. Danielle. Devlat. Takirov. Dennis. Idolis. It's I, right? I keep forgetting. E. I knew it. Okay. Yeah. Jared. J. Luis. J. Luis. Joshua. Justin. Caitlin. Kelly. Kyle. Letty. Muntaha. No. Niari. Niari. Nia. No. Nicholas. Nicholas S. Oresti. Rana. Ricardo. Taz, right? Taz Brown, last name Brown. Or Taj, G. Okay, Taj. Jaris, Bell. Mora. Here I had the last name Guzman. Okay. And Zichigao. 1, 2, 3, 4, 5, 6, 7, 8. 8 absent. Okay, ready? Nicholas I. Would you like to help me with the left one? No problem. I'm here to help you. So domain. Bracket 8. What type of bracket? Curly bracket. So here it's called curly with Y, right? Curly bracket. The curly here, curly bracket. Good. And then range? Good job. You got it. Be confident. Okay, volunteer. Ricardo. Domain. You're observing your left side. What is the lowest? What is the most left number you see in a graph? But the graph is going on forever and ever and ever and ever. Negative infinity. And this graph is also going up on and on forever. So what will be the rightmost number? infinity. Great. How about range? You're observing the lowest to the highest point. So this graph is going on forever and ever and ever, ever. Negative infinity to infinity. Ta-da. That's it. So any continuous graph has negative to positive infinity.
Here, the line is the y.
Why do you see 2y
In the graph?
here?
No.
Here? So it's going on forever, upward. I don't have space to going on forever, but the line is going on forever. So what is the highest height we have? Infinity. And since it goes forever on the right side, on the upward, it's also going forever on the right side. It's going slowly, but it will continuously go forever and ever and ever. So on the right side, it goes all the way to infinity. On the left side, it goes all the way to the negative infinity.
I got the first one I did, that's like the domain range.
Domain is x. So what x will we have in the graph? Go ahead.
For the domain, I have the same thing. But for the range,
Curly bracket is only for one number. So you're talking about here, right?
Yeah, for y, because I see that goes through.
It doesn't matter how it goes through. It matters what's the smallest y you have and what is the highest y you have. So it goes definitely through 2, right? It also goes through y value 1, y value 0, y value -1, y value -2, y value -10, right? The more it's going on, the more it's using y values. So here, y value here, another y value here, y value 10 is here. So the line is keep using all the y values. So if it's going on forever, what will be the highest y value it touch? Or what will be the lowest y value it touch? See? So what you see is the y-intercept, not the domain or range. Any other question? I love you guys when you ask questions because that means you're willing to learn, not acting like zombies or statues. You're a human being. And I love teaching human being instead of teaching statues. It's hard to read statues' mind, Okay, any question on domain and range? Okay, we are going to do the same thing, but this time we are going to use equation. What if we are not given the graph? Just a bunch of equations or functions. How do you know what's the domain and what's the range? Well, we have a problem. See here, when we see things, we can visualize them, we can understand what's going on. But for a function, when you don't see something, it's hard to visualize what's going on. So that's why you need to remember the types of function you're dealing with. There are so many types of functions we have. For example, parabola, it's a function. Lines, either increasing, decreasing, horizontal, they all are function. Cubic graph is a function. This thing is a function. This is also a function. This is also a function. These are also a function. Like we have so many types of functions, so many types of equations. So how do you know which one has what table domain? So we start to, in this class, we're going to talk about only 3 types of functions. One is polynomial, which includes the odd root also, and then even root and rational. So polynomial, all these things are polynomial. Polynomials are continuous forever, from left side to the right side. okay? So if you have a continuous function, like the left page, you see the domain is negative to positive infinity. Also, the horizontal line is a function. And look at the domain, negative to positive infinity. Look at this V. This V is also a function. It passed the vertical line test. So it's a function. Look at the domain, negative to positive infinity. So all these polynomials, they're continuous. Every continuous function has domain negative to positive infinity. So all real numbers means negative infinity to positive infinity. This one is the graph of a cubic root function. Cubic root, it's like cube root of x, or let's say fifth root of x. So in your radical, if you have an odd number, your function is continuous forever. So domain is negative to positive infinity. So for polynomial and odd root, we are safe. No problem at all. Domain is automatically all real numbers. And then our problem starts. First, we are dealing with a problematic function, even root function. For example, square root of x. It's called even root because its name is square root. Square means 2, 2 is an even number. Or if you have, let's say, fourth root of x, fourth root. So 4 is an even number, so it's an even root function. So every even root has a problem. Let's figure out what's the problem with the even roots. The even root. Let's look at few examples. What is square root of 100? It means what number when you square turns into 100? 10. What is square root of, let's say, 36? So what number when you square turn into 36? 6. What is square root of 1? Means which number when you square the result is 1? 1. What is square root of 0? Means what number when you square the result is 0? What number when you multiply twice turn into 0? Same number multiplied twice. 0. So square root means look for a number when you multiply the same thing twice, it becomes the number inside the radical. So 100 is 10 squared. So square root of 100 is 10. 36 is 6 squared. So square root of 36 is 6. 1 is 1 squared. So square root of 1 is 1. 0 is same as 0 times 0 or 0 squared. So square root of 0 is 0. Now, if I tell you what is square root of negative 1, means tell me a number when you square the result is negative 1. Can you also give me this answer? Same number multiplied twice, the result is a negative number. Is it possible? Impossible. And the impossible we denote with DNA doesn't exist. How about square root of negative 100? Still not possible. It doesn't matter what number you take. If you take positive number and multiply positive twice, the result is positive. If you take a negative number and multiply with another negative, the result is positive. So there is never, you can find a number when you multiply twice, the result will be a negative number. It's impossible. So what's wrong with even root? Even root can have positive inside, it can have 0 inside, but it cannot have negative inside. So even root problem is whatever we get inside, that must be 0 or positive, not x, okay? whatever we have inside the radical, whatever thing you have inside the radical, it must be either 0 or bigger than 0. So we start by identifying your problem. Once you know what is your problem, you set a condition. Our condition is the thing inside the radical will be bigger than or equal to 0, and then solve for the variable.
So I guess it would be the same thing outside the radical and not be negative either.
Outside the radical, we don't care. We care about the inside. The inside, it cannot have any negative. We can have 0, we can have positive, but negative, impossible. So you take whatever we have inside the radical, set it bigger than or equal to 0, and then solve for us. So that is our first type of problem. Then second type of problem, what if you have a rational function? Rational means fraction. So rational. Fraction. So if you look at the number line, we have negative infinity, 0, positive infinity, 1, 2, 3, da 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 da, negative 1, negative 2, da 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 da. So between every single numbers, we have so many decimals, right? We just don't see them. There's so many decimals we have here. So many decimals. Now, let's start with something good. 1 over 100. Is 1 over 100 a real number? Does it exist in your number line? It does, but if you're not sure, think about this. I'm giving you one candy and telling you to divide into 100 pieces. Maybe it's a big candy, a small one. Can you divide it into 100 pieces? Possible. Let's say I'm giving you 2 candies and asking you to divide it into 37 pieces. Is it still possible? It's not going to be easy, but still possible, right? If I give you, and since these are possible, obviously the opposites are possible. You just have to change them from right side to the left side, and you get the negative. So if 1 over 100 is possible, so is negative 1 over 100 is possible. If 2 over 37 is possible, so is negative 2 over 37 is possible. Right? So positive denominator is possible, negative denominator is possible. The numerator is telling us what we have, and denominator is telling us how many times you have to divide the numerator. Now, if I give you 1 candy and I tell you to divide into 0 pieces, how are you going to do that? Is it possible? You have 1 candy. How can you make it disappear? Dividing into 0 pieces means make it disappear. Unless you eat it, it's not going to be disappeared, right? So this task is impossible. If I give you a pen, you cannot eat this pen. Can you make it disappear? Oh, no. Unless you're a magician. They also don't make it disappear, they just hide it somewhere, right? They cannot make anything disappear. So what do you see? Positive denominator possible, negative denominator possible, but which denominator is not possible? 0. So from the number line, number line is inside our domain. Only one thing that cannot we have on the denominator. Not x. Okay, x cannot be 0. That's not true. Whatever we have on the denominator, that denominator cannot be 0. Denominator cannot be 0. So anytime you have any type of rational function, the only thing you look at for now in this class is the denominator. The denominator cannot be 0. So you take the denominator, set it. So our problem is denominator cannot be 0. Then we set a condition. Well, based on the problem, what condition we have? Denominator not be 0. Then solve for x from whatever we have on the denominator, and that will tell you what number it cannot take from your number line. For example, let's see here 1 over x plus 1. So in this function, what is our denominator? X plus 1. So this x plus 1 cannot be 0, and then solve for x. So to solve for x, what do you have to do? Subtract 1 from both sides. Subtract 1, subtract 1. So x cannot be what number? What is 0 minus 1? Negative 1. So it's not x cannot be 0. It's x cannot be negative 1. So instead of using our cross in the 0, we need to use our cross at negative 1. Because this function is fine with 2, 3, 5, 700, negative 7, negative 100, negative million. Everything gives us something good. But when you replace negative 1, you have negative 1 plus 1, which is 0. And 1 over 0 doesn't exist. So our domain is everything before negative 1, everything after negative 1. We just cannot take this negative 1. And these are the two types of problem we're going to see in this class, and that's how we solve them. So let's do some example. The first one is saying f of x equals negative 3x plus 5, and f of x is same as y. Y equals negative 3x plus 5. What type of function is this? Do you see any cubic root or fifth root? When you are dealing with root, you're going to see a root, this type of root. We don't see any root, right? But didn't you see this before? What type of function is this? A linear function. Yes, seen it so many times in the last 2 weeks. What type of line is this? Increasing, decreasing, horizontal, vertical? Decreasing. How do you know? Good job. Negative slope means it's a decreasing function. So it's going on forever and ever on the left side, forever and ever and ever on the right side. So what is its domain? Negative infinity to positive infinity. Any line has domain negative to positive infinity except vertical line. Because vertical line is not even a function.
Would it matter if you, let's see if it is around?
It does matter. In a number line, do you see bigger number on the left or the smaller number on the left? Smaller. So this is an interval from the number line. So you have to follow a smaller number and then the bigger number. Okay, so first type of question doesn't have any problem. So we don't have any problem, any condition. We just take everything from the number line and we can substitute in our line. And now starts a new problem. What type of equation, what type of function is this? What's the name of this type of function? Rational, good job. And what's wrong with rational? What's the problem? Denominator is our problem. So for every problem, we need to set a condition. What's the condition for any rational? Not equals to 0. Denominator cannot be 0.
The thing is that we have to like change the value, so we have to go to negative 3. So
Right. But your condition is whatever makes the denominator, it cannot take that. And cannot means not equal. So you start with your denominator. We have x plus 8. And that denominator definitely cannot be 0. And now solve for x. What do you do? Negative 8. We subtract. So x cannot be what number? Negative 8. So if you observe the number line, let me make the tiny number line here. We have negative infinity, positive infinity. We can take everything from the number line except negative 8. So we need to write this in interval notation. This is the visualization. What's happening? This is a graph of our solution. But what's the solution? What's the domain? So we have first interval here. Domain. Remember, domain is smallest to the largest. So in this tiny interval, what's the smallest thing you see? Negative infinity. Comma. And what's the largest thing you see in this tiny interval? Negative. You see negative 8, you don't see negative 7. You clearly see negative 8. But it cannot be negative 8. So when you cannot use something, what do you use? Parentheses or bracket? Bracket means you can. Cannot means it's a hole. You cannot use it because there's a hole there. So what does hole means? Cannot use it, so you have to be parentheses. So this is the left side of the interval. And then you skip 8, and then you look at the right side of the interval. So since there are two intervals, we need to put them together. We use U. U means union. It represents the plus sign. Means left interval plus the right interval. So in this right interval, what is the smallest number you see? Negative 8. You still don't see any other number because I did not write down. We still have negative 8, but can you use negative 8? No. So its boundary should be parentheses. And then what's the largest number you see? Positive infinity. And infinity always has parentheses because we can use them. There are infinity. We don't even know where infinity exists. Infinity doesn't exist, right? It's somewhere we can see. We add them using union sign. You cannot have entire interval as negative to positive infinity because there is one number you cannot use. So you need to break your interval into two pieces because of that thing we are not allowed to use. Any question?
Do you remember to add a union sign?
Anytime you have more than one interval, it's U between them. Okay, you try one. Find the domain. Finding range is hard, so we actually don't find range in lower classes. We always find domain. This will be in the exam. Or range for equation, we don't use them. I mean, lower level classes. For upper level classes like calculus 1, 2, 3, you're going to learn how to find range. Range is hard to see. So in the exam, I'm going to give all three: a polynomial, a rational, and an even root. So 3 domain questions from the equation, and then at least 2 to 3 domain questions from the graph. So everything you're learning to do in the exam. Find the domain in the interval notation. No problem. Same way. Fraction is a real number, it's allowed. Question or answer? Which one? You got it? What do you have?
The domain negative. G negative half.
You're very close. You forgot to change your sign. Here, go ahead. So you take the denominator 2x minus 1. This cannot be 0.
Profit is one
Mm-hmm.
in both sides, yeah. So then
2x cannot be 1. And then
divide the two both sides.
divide by 2. So x cannot be 1/2. So if you look at the number line, a tiny number line, negative to positive infinity, we can use everything. But we cannot, let me use red. It's danger. If you go near half, you are in danger. You're going to fall down in the hole. 1/2. Cannot use 1/2. So interval notation. Go ahead. Positive 1/2 and the boundary. Parentheses. Union. So this is this left portion. And now we are going to write the right portion. 1/2 and positive infinity. So you need to write this down in this format. So this is the left, this is the right, which you have here. Interval notation. And this is called graph. And this notation is called inequality notation. Any question? That was easy, right? If you understand, it's easy. So is there anybody who did not understand what's going on? Good observation. For any rational value domain, you'll always have parentheses. Always. And now comes our third problem. What type of function is this? What's the name of this type of function? Even root. Good job. Even root. And specifically, this one is square root. So square means 2, which is an even number. So we start with problem. What's wrong with even root function? What we cannot have? Negative. So even root cannot have negative inside the root. So whatever we have inside, that thing cannot be negative. So we set a condition. Condition. Inside the radical must be bigger than or equal 0. Whatever we have inside our radical, it could be a function, it could be a number, it could be anything. That thing inside the radical must be either 0 or bigger than 0 means positive. So what do we have this time inside our radical? What do you have inside the radical? What is this? 2x plus 1. So inside the radical, we have 2x plus 1. That 2x plus 1, not the x, the entire 2x plus 1 must be either positive or it can be equal 0. And now solve for x. So how do you solve for x? Subtract 1. So we get 2x has to be bigger than -1. And now divide by 2. So x has to be bigger than or equal -1/2. See, x can be -1/2. It's allowed. But the inside, the entire inside, that cannot be negative. Now put this on our interval. Negative to positive infinity. And it says, hey, start with x equals 1/2 and then take everything that is bigger than -1/2.
When we are writing, does it matter where we put the negative sign? Like if it's a fraction like that, if I put negative and then write 1/2, does it matter?
So let's say our -1/2 is here somewhere. So it says use -1/2. We are starting our journey from -1/2. And then you can substitute any number that is bigger than -1/2. So all these numbers we have here, they are bigger than -1/2. So how are you going to write this graph at the interval notation?
We can use something with some brackets. The bracket, -1/2, subtract, you can,
Parenthesis. So starting from here, everything else. Always. So square root will always be a bracket, but rational denominator will always have parentheses. At least in this class, okay? More a question?
No.
Anyone else have any questions?
Graded and equal is gonna be wrong, one.
Say it again.
If we don't put like graded and equal,
Mhm.
it's gonna be wrong.
Because greater than equal means only positive. Well, good. We know square root of positive number is positive number. It does exist. But what is square root of 0? Is 0. It also exists. So you have to say either it's equals to 0 or it can be bigger than 0 because both of them are valid. So if you omit your equal sign, that means you're giving only a portion of your solution, not the entire solution.
So on the class to show where it is, I can.
So this is what I expect to see in the exam. Figure out what's wrong in this function. What is your problem? Or what is your condition? And then solve for x. This one is optional. I like to do this because this helps me to visualize what's going on. And then this is the most important part. Show work, give me the interval notation. If it just give me the interval notation without showing work, it's 0. Okay? So must do all your work, show correct work, and then sorry, it's not a multiple choice. Give the correct interval notation. Even if it's a multiple choice, you have to pick the correct multiple choice for the final exam. No. Number one is for you to help you. Do I have an example? I don't. Any question? So with this, we are done with 3.6. Make sure you do all the sections in chapter 3, their homework and their quizzes. And now we are going to do 4.123. What's this one? So slow. Okay, chapter 4. In chapter 4, instead of using one line, we are going to use 2 lines. So if you observe chapter 3, in chapter 3, we only worked with 1 line. We found the x-intercept of the line, y-intercept, slope, how to graph, what is this parallel line, what is this perpendicular line. So you only concentrated on 1 line. But chapter 4 concentrates on 2 lines. What if you have 2 lines at the same time? What you're going to do? When you have 2 lines, we want to see where do they intersect. Do they intersect here? Do they intersect here? Or do they intersect here? Like how they intersect? If they do intersect, then those intersection is called solution. So when you have 2 lines, there are 3 ways they can intersect or they can interact with one another. Either they intersect at one point, like these examples. So they cross one another at one point. If you do have that situation, that means you have unique solution, means one solution. You have only one x value and only one y value. So where they intersect is the point. What's the point? The first term is the x, the second term is the y. Or the 2 lines you have, they are actually parallel lines. Do parallel lines ever intersect? Since they never intersect, so we get no solution. And then the third scenario. The 2 lines, they look a little different, but they are actually the same line, sitting top of one another. So once you modify, maybe you can see that, oh, they're the same line. So when you have 2 lines, the same line twice, how many intersections they have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How many intersections you can count? Infinite. So when you have same line, we have infinitely many solutions. When you have 2 parallel lines, we have no solution. And besides these 2 weird scenarios, every other time they will intersect at least once. And that one intersection is the solution of our system of equations. Now, when you do have a solution, those system of equations, we call them consistent systems. Means they're good, they have a solution. They may have one solution, but they may have 1,000 solutions, but they do have some solution. But if you're working with parallel lines, they have no solution. We call them inconsistent system. Means the 2 lines you have, they're bad. They never intersect. Okay. So the first thing we're going to do is verify. How do we verify whether a point is a solution for our system? So let's say you got some point. They give you some point, and you have to see like whether is it a solution or it doesn't make a solution for us. So to see that, you're going to plug that x and y value into both of the equations. And if the left side equals the right side in every equation, only then the number you're given to you is a solution for your system of equations. But if one of them is satisfied, other one doesn't, it's not a solution. Let's do one example. We have 3x minus 2y equals -13 and x plus 3y equals -3. So 2 lines, we want to see they intersect. Do they intersect at -5, -1? Is it? So we take both of them. 3x minus 2y equals -13. and x plus 3y equals -3. They're telling us, hey, your x is -5 and your y is -1. So replace all these x and y with -5 and -1. So the first one is 3 times -5 minus 2 times -1. The second one is -5 plus 3 times -1. And we'd like to see, after you combine these, do you get -13? After you combine these, do you get -3? If you do, then it's a solution. So let's see, what is 3 times -5? -15. And what is -2 times -1? +2. So what is -15 plus 2? -13. Do we have the same thing? Yes, we do. So this one satisfied. Now the next one, we have -5. And what is -3 times +1? -3. What is -5 minus 3? -8. But what do we have? Do you have the same number? No, not same as the MA. So it's not a solution. So basically that's giving us a point from the first line, but it doesn't intersect the second line exactly at that point. So here, nah, we wasted our time. But this is what you're going to do in your homework. They're going to give you a few questions and ask you to verify whether the point they're giving you is a solution or not.
So if it's not a solution,
That means there is a different solution we have. So go find the real solution.
wait, so would that be perpendicular or parallel?
Perpendicular, they do intersect. So they have a solution. Parallel lines, they don't have a solution because they never intersect. You don't know because we didn't solve them. They just gave us an option saying, hey, I'm giving you a number, check whether it's a solution. It's like cheating. Just guess a number and see if it's a solution or not. Well, too bad it's not a solution. So you really have to go and solve them to see what type of solution they have. And this is our next topic, how to solve it. So we have two lines. So one line, I'm not sure, probably is here. The other line is probably decreasing. So that point is not -5, -1. It's a different point. So how do you find that point? That's the next part of our lecture. But I'm not going to go over everything. I'm going to just briefly tell you how do you find that exact point. We have three methods. One is called graphing method. In graphing method, we plot both lines on the same XY plane. So here, and probably the other one is here, and then we see where do they intersect. That's our solution. But then it has a bad side, so it has a downside. What's the downside of this graphing method? Not time, actually. Time is one of the factors, definitely. But the other one is decimal. If your answer is not a whole number, how are you going to figure out what's the decimal here? You see? So this method is okay as long as you have graphing paper, your ruler, and the solution is a whole number. But if the solution is a decimal or fraction, you are doomed. Okay? So it has a bad side. So that's why we have other methods. The next method is called substitution method, which we are going to learn in our next class. In substitution method, we substitute one equation with another variable. Example here. We have x equals y plus 3. So instead of writing this x, we write 3 times y plus 3. So our entire first equation becomes something with y equals 7. So all you have to do is do algebra, solve for y. Once you solve for UI, substitute here, you get x. That's why this is called substitution. We substitute one variable with another variable and then do the math. The last method is called addition or elimination. It's called elimination because our goal is to eliminate one of the two variables. Either eliminate x or eliminate y. And in order to eliminate, we need to add the two equations. That's why it's called addition method or elimination method. For example, here, we have 3x plus 2y equals 4 and x minus 3y equals 17. Let's say I decided to eliminate x. So if I multiply this by -3, we get -3x, positive 9y, and positive, what is 17 times 3? 51. And then if we add these two equations, what happens to the x's? Plus 3x and minus 3x becomes what? Cancel out. So we eliminated our x, and what is left? Only the y's. 9 and 2 gives us 11, and this gives us 55. Can you solve for y easily? What do you get? Y equals 5. See, we can easily solve for one variable. And once you solve for one variable, we're going to substitute into one of these equations to get the other variable.
That's 51.
51 plus 4 on the top. So this is called elimination method. My favorite method is elimination method. We just eliminate one of them directly. And you can eliminate also y by multiplying both of them by same thing, both of them by different numbers, so it becomes same number. For example, we have x minus 3y equals -17, and we have 2y here, plus. So if you decide to eliminate y, let me erase everything else just for convenience. If you decide to eliminate y, you have to have the same coefficient with different sign. So what can you multiply by and what can you multiply by so that you're going to have the same coefficient? What can you multiply the -3 by? 2. So we got 2 times -3, which is -6y. Then what do you need to multiply these 2 by? 3. We want to have same but different sign, same number with different sign. So when you add, what happens? Cancel out. So that's why this is called elimination, because your goal is to eliminate. And it's also called addition because you need to add them to cancel out. So we are going to learn all three methods in our next class. And then we're going to learn about where actually in real life we apply them. So real life application. It will be fun. So enjoy your weekend. Don't forget to complete all the homework and quizzes on chapter 3. 3.6. So entire chapter 3 homework and quiz due next week, Tuesday midnight. Next week? Okay,